have seen the armature reactions in the case of DC machine. The armature reaction is the same in case of synchronous machine, but with the effect of load, with the change in load, it changes. So it sometimes it is cross magnetizing, sometimes it is magnetizing, and sometimes it is demagnetizing. We can have a look on the cases of different types, effect of armature reaction on different type of load. In the case of generator and motor, they are different. When it is unity power factor, when it is zero power factor, and lag and zero power factor lead. And I can have this table, and this is a very important table when objective type of questions are concerned. Please remember this table as it is. In the case of generator and in the case of motor. In the case of generator and the motor, at the unity power factor, it is always cross magnetizing. In the unity power factor, armature reaction is always cross magnetizing, whether it is working as a generator or whether it is working as a motor. In the case when it is working as a zero power factor lagging, it is working as a zero power factor lagging. Here it is demagnetizing in nature. In the case of generator and magnetizing in the case of motor. And in the case of zero power factor leading, in the case generator is concerned, it is magnetizing in nature, and in the case of motor, it is demagnetizing in nature. This is a very important table when effect of armature reaction on different type of loads are concerned. When the load is of unity power factor, again it is cross magnetizing when it is generator, and it is cross magnetizing in the case of motor 2. In the case of zero power factor lagging, it is demagnetizing in the case of generator, and it is magnetizing in the case of motor. In the zero power factor leading, it is magnetizing in nature in the case of generator and demagnetizing in the case of motor. Please remember this for objective type of questions. We know what is called a voltage regulation. In the transformer also, in the induction machine and transmission lines, we have already studied the phenomenon called voltage regulation. It is the change in the secondary full load current when it is thrown from no load to full load, and voltage which is getting changed is called the voltage regulation. So Normally, in synchronous machine, there are three different methods by which the voltage regulation of the machine can be formed. First of all, first is called the EMF or your synchronous impedance method. Second is normally called as ampere turn method or your MMF method. Of course, the synchronous impedance method is also called as the EMF method. The third method, which is normally known as the Pointer triangle method or the ZPF method. In the synchronous impedance method, it's the open circuit and short circuit test. It's a simple test. Open circuit and short circuit test are found, and open circuit characteristics and short circuit characteristics are drawn. And from that, we can find Z0 is equals to E0 upon ISC. And for that is very simple. And we know from EMF method it is very easy. The very important point here is that the open circuit characteristic and the short circuit characteristic, which we will be seeing in a few moments, and the thing which is very important that the advantages of the your synchronous impedance method or your EMF methods are it is very easy to conduct because it's a no-load test first of all. If we talk about this thing, first thing, and the second thing, it is very simple to conduct since it's a no-load test, and method is the same which we have studied in transformer and your induction machine and all that. The open circuit characteristics will be drawing and short circuit characteristics we will be drawing, and from that we will be finding the voltage regulation. The only disadvantage of this method is that this is a pessimistic method. This method, your EMF method, is normally known as the pessimistic method. This is very important point. Please remember this thing. It's a pessimistic method because of the reason that the value which we are getting from EMF method is always higher than the actual value. So it is normally known as the pessimistic method. Please remember this thing. Coming to the ampere turn method, in this method it is just like your EMF method where the phasor sum of EMF were actually added or they were there and we were finding the voltage evolution from that. In the ampere turn method or in the your MMM method, we are actually finding the MMF of the phasors, and from that we are finding the voltage regulation. So it is normally called as the optimistic method. because of the reason that if the value which we are getting here is below the actual value, it is called optimistic method, and the ZPF method is the most accurate method. This is the most accurate method by which anyone can find the voltage regulation of the synchronous machine. So please remember this thing also. This is the most accurate method would be a Portier triangle method. First of all, second thing, the method ampere turn method would be the best one. Third would be the synchronous impedance method. So in the increasing order, or in the decreasing order of their priorities, if you are supposed to find the voltage regulation, the decreasing order of the priorities of the finding the voltage regulation of synchronous machine would be like Portier or ZPF method. The second would be ampere turn method, and the third would be your EMF method, or which is also known as the synchronous impedance method.